Hey guys, so today we're going to talk about terminating decimals and fraction to decimal. So what I want to tell you is what I used to use back in the day when I was here the first time. A lot of times students get really confused on when you're turning a fraction into a decimal, which number goes in the division box, right? So if we had, I don't know, let's say 2/5, okay? And we want to turn 2/5 into from a fraction to a decimal. I would always say TIBO it. TIBO, not as in Tim Tebow, but as in top in, bottom out. TIBO, TIBO it. The top number goes in the box, the bottom number goes out. Top in, bottom out. Okay, so if you want to write that down, you can do that. It is, and I guess it would be better to do it like this. TIBO, TIBO, and it stands for top in, bottom out. Okay? So if you ever hear me go, TIBO it, I'm talking about put this top number in the division box and the bottom number goes outside. So if you were to look at it, you have your division box, fancy. This top number is going to go in it. Top in, bottom outside. Okay? Now that may help you, may not, but it helped me. So, and it helped my students I've had in the past. So, can 5 go into 2? Can it fit inside this 2? Can I take 2? Can my 5 fit in it? No, it can't. So what we got to do is add a decimal. So we add a decimal right here, and you remember you have to bring it up, bring your decimal up, and then you're going to add a 0 to that. Okay, now, can 5 fit into 20? Because 5 can't go into 2. But can 5 go into 20? Yes. How many times? 4 times. Okay? And ignore the decimal, but 4 times 5 is 20, right? Okay. So now we have it right here. Okay? 4/10 or 0.4. I'm not very picky. But let's say we had something a little more confusing, a little more difficult. And a lot of times it's going to be rounding to the nearest thousandth, okay? So let's say, for example, that we had 1/3, okay? 1/3. All right, now, I want to get this as a decimal. Top in, bottom out. Top number goes in the division box, 1. The bottom number goes out. All right, now, can 3 fit into 1? Can I fit my 3 inside this 1? No. So I'm going to put a 0. And my next step is to add a decimal. Add a decimal. Bring it up. Add a 0. Can 3 fit into 10? Yes. 9 times, right? Or 3 times, I'm sorry. 3 times, right? 3. And the way you figure this out is, we know it can't fit in there 1 time because 3 times 1 is 3. What about 3 times 2? 6, yes. But can I get closer to 10 without going over? 3 times 3, 9. Yes. I'm really close to 10 when I'm going over. And just to prove a point, 3 times 4 is 12. 12 is bigger than 10. So I've got to stop at 3. 3 times 3 is 9, right? 10 minus 9 is 1. Okay? Can 3 fit into there? No. So I have to add another 0, bring it down. Now, 3 will fit into 10. 3 times 3 is 9, right? I'm not going over 10. Okay, so 3 times 3 is 9. And I've got 1 again. So what am I doing? This is insanity. And what do they say the definition of insanity is? Repeating the same thing over and over and over and trying to expect a different outcome. Okay, so if I'm going to just keep on doing this over and over, I'm just going to continue to have 3, right? Right. Now, what I personally would like, well, you gotta see what the question is asking. What's the question asking me? That's where I determine where my terminating decimal is, you know. So my decimal number is 0.333. What is repeating over and over? The 3. So you can actually write that, technically. You could do 0.3, and this line above it means it's repeating. Now, if we had a, let's